The PoolParty thesaurus editor allows users to create and edit controlled vocabularies based on discussed data schemas. Each controlled vocabulary is managed as a project and organized in a tree-like structure. A project can contain multiple concept schemes at the first level, top concepts at the second level, and an arbitrary number of concepts at consecutive levels. Descriptive information, such as hierarchical neighbors or labels, can be assigned and managed for each concept. The editor also allows for lightweight ontology construction, such as definition of custom classes, relations, or attributes. Moreover, existing data schemas on the web, like FOV or geonames, can be used to state additional facts in the taxonomy that are not covered by SCOS. PoolParty uses a triple store for persisting all controlled vocabulary information. Its internal algorithms expect the data to meet certain criteria, like, for example, each thesaurus concept being part of a hierarchy and having a proper label. Conformance to these criteria is ensured by the application logic and the user interface. However, data consistency violations can be introduced by, for example, implementation bugs or imported data from third-party projects. In the first year of the Aligned project, we focused on establishing a representative set of 16 consistency violations and demonstrate them in case they occur on imported data. For this reason, we adapted the data import dialog by adding an option that checks the data for compliance to these consistency constraints. One consistency constraint is that PoolParty requires each concept to point to its broader concepts, which must in turn reference all their narrower concepts. If we import a dataset that does not stick to this requirement, the user interface reflects this missing data by inconsistent behavior. Here, the concept imported top concept does not show up in the listing of the broader concepts. Now, we import the same dataset with the option for data consistency checks enabled. As a result, we get a report of what consistency requirements have failed. In this case, the user can see that the concept with the URI import3 missed required information as it does not reference its broader concept. We can also use RDF unit for performing these checks and create a report. This can be invoked by clicking the link Download RDF Unit Report. This takes us to the HTML page that is generated by RDF Unit. We currently have covered 4 of all of the 16 identified consistency constraints to be used with RDF Unit, which is indicated on the page as total test cases. When working with large thesauri, sometimes duplicate concepts are created. They describe the same object in the real world, but have no relation to each other. These duplicates can, to some extent, be detected by checking whether some of their labels are identical. When importing RDF data which contains potential duplicates, we can see them in the user interface as identically labeled tree members. This requires users actively click each of the concepts and see their descriptions in order to disambiguate them. Thesaurus developers may want to merge these concepts or find better names for them. By activating the newly developed consistency checks and importing the same data, we get an error indicating that the two concepts with the URIs import2 and import3 may constitute duplicates. We found that the specification of data consistency constraints using Sparkle separated from application logic implementation adds an additional layer of complexity to our product. Data constraints must therefore be integrated with a central application data model that drives access to the underlying data store and generation of user interfaces. The currently very active W3C working group for RDF data shapes provides a promising approach for tackling this problem. Besides reporting data consistency constraint violations, we will investigate how to integrate repair strategies into the formalized constraints that can automatically fix the detected constraint violations in a specified way. In addition, we plan to exploit the insights from the consistency constraint checks in our development process. We will aggregate and analyze them in order to see what consistency violations occur most frequently. They will serve us with additional feedback to improve PoolParty's ability to cope with data from different sources.